Okay, so all right, let's see, minimize this out of the way. Okay. So quiz number 2. All right, so quiz number 2. Okay, so quiz number 2. So pretty much, so this is just a basic concept of from the DC. So you can find most of these answers from the DC fundamental handouts. Okay, so question number 1: when the voltage is indicated at some point in the circuit, the voltage is actually between that point and a reference point. Okay, so therefore, if I say point C example, and usually we take the reference point. If it's at only point C, then the reference point has to be at the ground level. So it's from point C to the ground. So between that point and the reference point. So the answer is A as in apple for number 1. Okay, in a series circuit, the current is, there's only one current in the series circuit. So it's going to be flowing this way. Okay, there's only one, so the same in all part of the circuit. So the answer is B as in Bob for number 2. Okay, number 3, in a series circuit, the source voltage, okay, source voltage here. Okay, it would equal to the voltage drop at each of the resistant location. So it's going to be like here. Okay, so you got the voltage, so VR1, for example. So you got that, and the voltage drop over R2, voltage over R3. So that the voltage drop added together equal to whatever we apply into the circuit, the VA. Okay, in this case, this is the E. So the answer is so the answer equal to the sum voltage across the component. So the answer is A as an apple for number 3. Okay, any question number 1, 2, or 3? Okay, no question. All right, next set. Okay, number 4, in a series circuit, the total resistance. So you just total resistance, you just add them all together. R1 plus R2 plus R3 is equal to the sum of individual resistance. So answer C as in cat for number 4. Number 5, if the voltage source in the figures above is increased from 10 volt to 20 volt, then so you increase the sources from 10 volt to 20 volt, then the voltage across R1, R2, and R3 would also double, okay? So if you increase the source voltage, then the voltage over each one will also double that. So the answer is B as in Bob for number 5. Okay, any question number 4 or 5? Okay, no question. Next set. Okay, number 6. Okay, in this circuit, if R3 increased from 1.5 kilo ohm to 3 kilo ohm, okay, so you're increasing the resistance of R3. Okay, so you double the R3. So if you increase your resistance, so your current would be decreasing. So the answer is, so the only one that has decrease in it is B as in Bob for number 6. Okay. So number 7, a decrease in the current in series circuit can be caused by, okay, so you decrease the current, so you have to increase the resistance. So the answer is C as in cat for number 7. So any question number 6 or 7? Okay, no question. Okay, next set. Okay, so number 8, when the resistance of a series string decreases, the current would increase. So you got the, okay, so decrease in resistance, so resistance is going to go down. So therefore your current would go up. So therefore the answer is B as in Bob for number 8. Okay, number 9, when resistance is added in parallel, total current would increase. So if you if you add a resistance into parallel, you would decrease the resistance. Okay, so equivalent resistance is less than the smallest branch resistance. So therefore, Anything that add into a parallel, your resistance would decrease, therefore your current would increase. So the answer is C as in cat for number 9. Okay. Number 10, when two resistance are connected in parallel, okay, so the voltage across each is the same. Okay, when you measure parallel, that's so therefore whatever the resistance, so the voltage apply to the same to all the resistance. You have only one voltage. Okay, so the answer is B as in Bob for number 10. So voltage is the same across each branch of the circuit. That is from the handout, from the DC fundamental handout. Okay, so any question number 8, 9, or 10? Okay, no question there. Okay, page down. Okay, number 11, the branch voltage and a parallel circuit is equal to the source voltage. Okay, so you got here, so VA would apply right here, right here, right here. So there's no matter what, it's always going to give equal to the VA. So the answer is A as an apple for number 11. Okay, number 12, the current in a parallel circuit is, okay, so current, so therefore you're going to have, this one is going to get divided. So it's going to be some currents going down this way, some going down this way, some will go down this branch, okay? So if you add them all together, that would equal your total current, okay? So the answer is D as in David for number 12, okay? Equal to the sum of all branch current. Okay. Number 13, the total current for the circuit is, okay, so in this case, you do the calculation, okay? So you got, so your formula I total equal to IR1 plus IR2 plus IR3, okay? So to find IR1 is VA divided by R1 and IR2 is VA divided by R2 and current that's going R3 is VA divided by R3. So you do that calculation and it comes up to about 28.5 milliamps. So the answer is D as in David for number 13. So any question number 11, 12, or 13? Okay, no question. Next set. Okay. Okay, number 14, if a 700 ohms resistor were added in parallel with the resistor above, the equivalent resistance would be, okay, so you got R1, R2, R3, and then they're gonna put another resistance, which we R4, which will represent 700 ohms, okay? So your R equivalent is equal to 1 divided by the quantity, 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over the R unknown or the N resistant. Okay, so therefore, if you put in the calculator, so you do this calculation, it should comes into about, oops, I forgot to delete that. Okay, so sum totals come to 350 ohms. Okay, so the answer is A as an apple for number 14. Okay. Number 15, when you connect a multimeter in a parallel circuit to measure the total circuit current, okay, the meter is connected in series between the source voltage and the first branch. Okay, so similar to this one, but we're going to be like open up and we'll put the meters either close at the power at the voltage source, which is would be right here. That would show you, so the meter is connected. So the answer is B as in Bob for number 15. The meter is connected in parallel, it's in series between the source voltage and the first branch. Okay. And except I showed on a series circuit. Okay. So any question number 14 or 15? Okay, no question. Next set. Okay, number 16, if R3 is open, total circuit current would be, okay. So if this one is taken out or been, so this one is not connected in circuit, So therefore your resistance would increases. So if your resistance increases, therefore your current would decreases. Okay, so this one the circuit current. So if you remove that, you only have R1 and R2. So you add those two together. So that's come to about 1530 ohms. So the answer is A as an apple for number 16. Okay, number 17, if R1 is shorted, okay, so R1 is shorted here, and therefore, so if you short it here, which is in series, so therefore now you're going to be decreasing the resistance, okay, because these two is in parallel. So your resistance would decreases, so resistance decreases, therefore your current would increases. So the answer is A as an apple for number 17. Okay, any question number 16 or 17? Okay, no question. Next up. Okay, so number 18, a 5 ohm resistor connected to a 20 volt DC source will dissipate. Okay, so this is the looking for power. Okay, so it's giving the voltage, we know. So power equals V squared divided by R. Okay, so 20 volt squared divided by 5 ohms. Okay, so if you do that calculation, it should come up to 80 watt. So the answer is C as in cat for 18. Number 19, in electric circuit where the source voltage is 120 volt and the total circuit current is 5 amp, how much power is being used? Okay, so power equals I times V. Okay, so therefore we got current is 5 amps times 120 volt. So that's come to 600 watt. So the answer is A as an apple for 19. Number 20, total power in a series circuit is equal to, okay, so the sum of the power dissipated by each resistance, that is B as in Bob for number 20. Okay, so this is from the DC fundamental handout. Total power is equal to the sum of the power dissipated by each resistance. Okay, so the answer is B right there. So like I said, most of these, by using the handout, it would all, that will help you with answering these questions. Okay, so that basic handout, it's really critical that you understand. Make sure you go back through it again and again to make sure you're familiar with it. Okay, so any question number 18, 19, or 20? Okay, no question. Okay, thank you very much. Back to you, Mr. Pham. Thank you.
Thank you, Sam.
You're welcome.
Okay, so make sure everyone register. If you're not, let us know so we can help you. And any question to me before we start with the lecture again? Okay, yesterday, we're already talking about inductor. Okay, inductor for the DC, they just like wire, nothing else. However, for the AC circuit, inductor, we get the resistance. Okay, and that's what they call inductive reactance, IL. And we calculate by the formula. IL equal to pi FL. In this formula, F have to be in Hertz, L have to be in Henry, and IL will be in Ohm. And yesterday we already given to you example number 5. Okay, they want to know IL. Okay, and that we already did it. If you get a question, let me know. Let's see. On that one, they gave a total voltage 50 volt AC. IL equal 1.885 kilo ohm, L 15 millihenry. The question is they want to calculate the F. And also they want to know the I. Okay. So let's see. You know the formula. U by F L. Okay. You don't know F. Okay. And also you want to get the IL. Equal V total divide to I total. Okay, how can we get that one? Sorry, I equal that given to you. V total is 50. 1.885. KO. Okay, so you know you can calculate the I.
26.5 milliamps.
Okay. 26.5 milliamp. And that will be telling you, okay. Now let's see. You already know IL. That one you already know. L, you already know. So you're able to calculate the F. What F equal?
That's gonna be 20 kilohertz.
Okay, one student got 20.
I also got 20 kilohertz.
Same thing?
Yes.
That's correct. That's just a very, very basic, okay? If you know the formula, and not the problem. Now, we get up to the IL and R in series. Last time we already talking about IC capacitor in series with resistor. And now we deal with inductor in series with resistor. Okay, see what they said. The current I total is the same. The thing is that the series circuit current will be the same R1, the same L1. The voltage VR in phase with the I total. We already know VR, IR in phase. Okay, They don't have any phase difference. What happened to VL and IL? Like we already said, IL leading VL. Now VL leading IL 90 degrees. Okay. So to calculate the total impedance, you cannot adding 50 ohm to 50 ohm. The reason is they not in phase. So that's why you have to using square root R square plus HL square. Okay. And after you get the total impedance, you're going to calculate the total current. You take the total voltage divide to total impedance. That has to be HL. That means G total. Voltage across the resistor I times R. Voltage across L I times HL. The phase angle between total voltage and the total current 10 minus 1 HL over R. Now, based on the formula we just give it to you, can you do a calculation for me? G total. You know that square root R square HL square.
You get 50 root 2.
Can you say again?
Get 50 root 2.
15
50 root 2.
of 50 ohm, right?
Oh, 50 times the square root of 2. Or 70.71 ohms.
70 point. Correct?
Yes.
Okay. I total. V total.
$1.41 amps.
Okay. 1.4 amp. Okay. VR. I total 1.4 times 50. 70, right?
That is correct.
VL. I total. HL. Same thing, right?
Yes.
Okay. Finally, angle. Okay. Will be 10 XL see XL
Pi over 4 or 45 degrees.
45 degrees. Basically, if you now understand the formula, the calculation is not a problem. Okay, so for this example, number 6, any question, and it's still not clear to you. Make sure for the inductance circuitry, very important to you to memorize either VL leading IL 90 degrees. That's the key point.
Wait. I'm still writing.
Okay, now go ahead and do it for this thing for me. I'm not giving you the formula again, but I want to know.
Mr. Pham, they were writing, they wanted you to go back.
If you're done, let me know.
Can you review the question number 5, phase angle between VT and IT? The equation is tangent of -1 or tangent -1 on the.
Okay, that's what I'm talking about when you're using your calculator.
Okay, I'm going to put tangent, negative tangent of XL divided by R to get
Okay. I tell you,
the.
XL equal 70, right? Divide to R 50. That's what number you get. Okay. Then now you can press 10 minus 1. Let's see. XL equal 50, sorry. 50 divided to 50.
Hey, Mr. Pham, can I say one thing?
Yeah,
Okay, for the students, if you hit tangent, that gives you like the decimal or 1 or whatever the ratio. But tan -1, that's the same as saying arctan, which means you want to get the angle.
exactly. So that's why I said, in order to do it, normally you have to use your calculator. First thing you press XL is 50, divide R. 50, you get 1.
Right.
In order to get an angle, Press 10 minus 1.
10.
That's what they given you 45. Press
On your calculator, there's a button that says tan, and then there's a button that says tan minus 1.
on the calculator.
Correct. And you press tan minus 1 to get the angle.
Make sure you can get 45 degrees. You have to know which one is 10 minus 1 in the calculator.
Oh, okay, I have to, on the calculator, my phone says, there's a number that button that says second. And when I press it, that's when I could see the 10 minus 1 button. Okay, got it.
Got it?
Yes.
Okay.
I found the button. Thank you.
Okay.
With the
Now, you guys try that one for me. The thing is, we just go to now one time, and we're not going back until you get the quiz. So number 1, I want G total.
50 ohms.
What value?
50 ohms.
50 ohm. Number 2, I total. You know the formula will be V total divide Z total. 50 divide 50, you get 1 amp. Number 3, VR. I times R. 1 amp times 30, you get 30 volt. Number 4, VL. Okay, so you get 40 times 1. 40 volt. And number 5, 10 minus 1.
Get approximately 53.13 degrees.
Okay, I get 40, 30. Okay, yeah, just a minute. Okay, and you take then 53.1. That's correct.
That is correct.
Correct. Got it too.
Get it?
Yes, sir.
Yeah. Now we go to the next one. IKLR in parallel. You get IL and I parallel, okay? See what they said. The voltage total, the same. Voltage across L or R will be the same. The current IR through R is in phase with the V total, okay? Let's see what they said in here. IR in phase. V total. You know how? Why? Why they said IR in phase with V total?
Because VR is in phase with VT.
You already know. V total, VL. Correct? All of the voltage across the component will be the same.
In parallel, voltage is the same.
So IR in phase with VR. Okay? IR. So that's why they say IR in phase with V total. What happened for the IL and VL? You know, VL lead IL. This is the formula, okay? We not make it up. VL lead IL 90 degrees. So what they said in here, the VRT equal VR RVL, same VL lead IL 90 degrees. So that will be telling you IR lead IL. -90 degrees. Okay. And the relation between total current and the total voltage, they said I total last VT 90 degrees or VT least IT 90 degrees. Okay. And now they're telling you, if you want to calculate the current IL, you take V total divide IL, current through IR, V total divide to R. However, if you want to calculate the total current, you cannot add in IL, IR. The thing is they not in phase. Then you have to using the formula, square root IL square, lot IR square. Okay. Then if you want the total impedance, you just take the total voltage divide total current. And the phase angle, that will be 10 minus 1 of minus IL divide IR. Okay, try to apply that formula into this circuitry, telling me current through L1, number 1. IL. You know IL, you know total voltage. So basically 100 divided 50, you get 2 ampere. I believe so.
That's right.
Current through R1. Same thing. 100 divided 50 ohm. And the total current you have to use in square root IL plus IL square. That means 2 square plus 2 square means 8.
Square root of 8 is 2.828.
Okay. Two point 828, right?
Correct, 2.828. That's the answer to number 3.
Okay. Okay, and you want the total impedance. V total. Okay, V total is 100 divided 2.83. $55.3.
I got 35.2.
35, correct.
Yeah, I got that too, 35.335.
And last one, fair. Minus IL over IR.
Negative 45.
Negative 45, right? Okay, try to see you can get that, understand or not the answer for number 8 example. Okay, and the question on RL in parallel. Normally for your job interview, they're not asking you to do the calculation. But they can get a question for this circuitry, how do we calculate the total current? Then the answer will be, you can calculate the IL, you can calculate the IR, And the I total will be square root. IR square plus IL square. The thing is, IL, IR, they're not in phase.
Hey, Mr. Pham, can you just repeat one more time why you said the minus sign goes in front of the IL on the
IR,
on the inverse tangent, on the angle?
yeah. On that one, theta content minus 1. Okay. Minus IL over R. Okay. How can we get that? Again, I try to make sure you know how to draw the vector. Okay.
Oh, okay.
That's what you have to know. That will be, if you want to draw IR, IR must be go this way. IR will be 0 degree. Now, IL, we already know IR leading IL 90. So if IL go this way, that means IL leading. So they have to be going down. That will be IL. Okay? And now you can draw the vector here, IR. IL going down. When you connect that one here, that will be I total. And the angle here will be minus theta.
Oh, yeah.
Okay?
Yeah, got it. Okay, yeah.
So that's why you can see theta equal minus IL, okay, going down, divide IR. That relates to trigonometry.
Mhm. And which one you said was leading again?
If IL leading,
Okay, IL lead.
then the IL have to be going up. If they leading. If they're not leading, lagging, they have to go down.
Okay. So IL is lagging in this case.
Right.
Got it.
Okay, one more for calculation. Then we'll be done with RL theory, RL parallel. Just giving me the value, okay? 1 IL. IL equal V12 volt divide 40.
Zero, 0.3.
0.3, okay, amp, correct?
Yeah, that's amp.
But they want milliamp,
300.
300,
Move the decimal point.
right.
There we go.
Number 2, IR,
0.4 or 400 milli.
And number 3, total current.
0.5 amps or 500 milliamps.
Can you repeat for me?
0.5 amps or 500 milliamps.
0.5, right? Amp. 500. And G total. Okay, V total divide I total. 112 volt divide 0.5.
24 ohms.
24. Okay, ohm. Last one. Angle. Okay, will be IL 0.3 divide IR 0.4.
Negative 36.87 degrees. Once again, negative 36.87.
36.87. Okay, make sure if you get the same answer, let me know. Otherwise, that will be done for this example 9 on the calculation. So, I did it, same thing. I did it. I mean, you really understand. So when you go into the college, go to the university, when they're talking about AC, that will be giving you a very, very good basic to understand. They will be the same thing. Okay, any question up to this point? Okay, if it's not, then we will go to the next one. Make sure you have to download it. Okay, that will be LC. Make sure you must be downloaded the handout. So let's see what next. Now we'll be learning only L and C in series. Then L and C in parallel. And the next meeting will be RLC in series and RLC in parallel. The one I'm teaching you here, that's the basics to solve the problem. You understand? And after that, we'll be teaching another way. Okay? They can do the same thing to solve the problem. Either way you want to do, that be fine to me. Now, we're talking about HL, HC. For the circuit with HLHC in series, the net reactant HT is the difference between your reactant value because for the series LC, HL and HC are 180 degrees out of phase. Okay, all the time, you need to remember, HL, HC will be opposite. HL go up, HC go down. Okay, that will be 180 degrees out of phase. For HL, HC in parallel, the total current IT is the difference between two reactive branch current, IL and IC. This is because IL, IC also 180 degrees out of phase. So, what you need to memorize for the series, okay, IC, HL will be 180 degrees out of phase. HL go up, HC go down. However, for parallel, then we deal with the IL and IC. Okay, IL, IC, 180 degrees out of phase. Now, first thing we're talking about, HL, HC in series. You see on this circuitry, 120 volt, you get HL. HL equal 160 ohm. HC 120 ohm. Okay. For the circuit show, cannot solving the circuit with both L and C. You cannot solving the circuitry with both L and C. The thing that they will be opposite, 180 degree out of phase. So now, what they're telling you, you have to come up with the circuitry either HL or HC. Either one, they don't care, but they have to be one, cannot be both. Okay? So, you can see the drawing here. HL 160 ohm, they go up. HC 120 ohm, they going down. So now by looking into the display here, you can see what the difference between HL, HC. How many ohm?
Positive 40 ohms.
Again, what I'm saying is, HL 160 ohm. They leading HC, they go up, value 160 ohm. HC lagging. So opposite to HL, they go down at 120 ohm. So the net resistance different. How many ohm?
She said, the lady said, positive 40. 160 minus 20 is
Exactly.
40.
Exactly.
That's what she said. She gave the answer.
Yeah, the thing is, I couldn't recognize. Sorry. Okay, you take 160 minus 120, you get 40 ohm. So now the circuitry will be get only one 40 ohm, but that will be HL or HC.
XL.
HL. The thing is HL higher than HC. So again, when you get both HL, HC, you cannot solving any problem. You must come up with HL circuitry or HC circuitry depend on which one will be higher. For this example, I get 160, I say 120, so you take it. 160 minus 120, you can get 40. That 40 will be XL. Now, you see. So, if you're looking here, this is the original circuitry. And after you calculate it, you go to another circuit. However, this circuitry with HL equal 40. So now you get only HL. Easy for you to calculate the current. You take the voltage, divide HL, you get the current. And that current will be right here. Okay, now, see what they said. Need to calculate the net reactant, IT. IT equal HL minus HC, or IT equal HC minus HL. Depend on which one will be bigger. Okay, and they're telling you, if HL higher than HC, the circuitry now will be inductive. Okay, however, if HC greater than HL, the circuitry will be capacitive. Okay, for this circuit, IT equal 40 ohm. Therefore, circuit is inductive with HL the same with IT equal 40 ohm. Now you can calculate the total current, I total. For this circuit, I total equal VT divide IT. 120 divide 40, you get 3 amp. Now, after you get the current flowing here, 3 amp, you can calculate the VL, I total time HL. 3 amp times 160, you get 480 volt. And VCIT times HC, okay? They will be 3 amp times 120. That's wrong here. That has to be 3. You get 360 volt. Okay, any question up to this point? For the RC circuitry, you have to find, is it that the RL or RC circuit only, not RCL, not C and L only, okay? You must come up with only one. Inductive or capacity circuit. By calculate the different inductor, inductive or capacity reactant. That's what they're telling you. You can take HL minus HC or HC minus HL. Okay? If HL greater than HC, the circuitry now inductive. Otherwise, circuitry will be capacitive. From that, the new circuitry, you're able to calculate the total current. That current will be go to original circuitry here. You're able to calculate the VL or VC. Okay, now you shown for me that circuitry. 130 ohm, 150 ohm. They want to know IT.
That's just a typo, Mr. Pham. C1 is XC. In the picture,
Oh, okay. Yeah, sorry. I will correct that.
That's XC.
Okay, so IT greater than IL.
50 minus 30 is 20.
Equal 20.
20.
Okay. So in circuit A, capacity. You know why? The thing is, IC higher than
XL.
IL. And they want. So basically the circuitry, if you copy it down, then you can see. And that will be IT20. And now you can calculate the current I total.
120 divided by 20, which is 6.
Okay, V total divide IT. So 120 divide 20, got to get 6
6.
amp. And now you can calculate the VL. 6 times 30. And VC. 6 times 50. Equal 300.
And Mr. Pham, I know, I pretty much understand it, but since XC is greater than XL, why do we care about that last part, what you just did? I'm just asking, why do we care about it since the circuit is predominantly capacitive?
You're talking about yesterday?
No, just what we're talking about right now.
Okay.
Well, the circuit X of C is bigger than X of L. 50 minus 30 is 20. So,
Yeah.
so the circuit is primarily capacitive.
Right.
The part where you did VL and VC, I was wondering, why is that necessary if the circuit is primary capacitive?
No. The primary that's helping you to calculate the current. If they want you to calculate the current, okay, the voltage in here,
Mhm.
how do we calculate it?
Yeah, you need to know the current. I understand that.
You have to get the current.
Yeah.
And
But
you
the-
cannot take your 120 divide 50 plus 30.
Mhm.
Why? The thing is they opposite.
Right.
That's why we have to come up with either one in order to get the current. Okay, any question up to this point? Okay, if it's not. Now, this is maybe the last one. IC now in parallel. For the circuit show, let's see, the brand current ILIC will be 180-degree our phase. Must be come up with either IL or IC. You see that for the series they calculate by IC. However, for the parallel, they get a different ILIC. And ILIC the same thing, 180-degree our phase. So you have to come up with the circuitry, a L circuitry or C circuit, depending on the current. Okay, so now if IL higher than IC, circuitry will be inductive. IC higher than IL, they will be capacitive. To find the total impedance, G total equal V total divide IT. Okay, now let's see. You want to calculate the IL. You get a voltage 120 volt here. They get 40 ohm. Easy for you to get the current IL. 120 divided to 40, you get 3 amp. If you calculate IC, 120 divided 30 ohm, you get 4 amp. So now you have to see which current will be bigger. Based on the calculation, IC higher than IL. Okay? And if you're looking in here, IC will be leading IL 90 degrees. Then the value will be opposite. IC 4 amp and IL 3 amp. Okay. The net circuit is capacity and the net current is IT equal IC minus IL. That means after you combine, you get the current will be only 1 amp, but the circuitry will be capacity. Okay. This they show you the phasor IL and IC. Okay. So we need to do in calculation on that one. 120 volt, 50 ohm, 20 ohm. First thing, they want to know the net current. That will be telling you, you need to know IC. Okay, V divide IC. So 120 divide 50.
2.4. That's 2.4, the first one, Mr. Brown.
2.4. And now you need to calculate the IL.
That's 6.
Okay, 120 divide, that will be 6, right?
Mm-hmm.
So now you can see IL higher than IC. Okay, so basically you can see I equal IL minus IC equal
3.6.
3.4, right? Or
3.6.
3.6.
Okay, 3.6. Yeah. So that's what they call IT. Or I can call I or IT will be the same thing. Okay. So after I get the I total IT or I, then I can say the circuitry now will be inducted. Make sure you understand how come we come up with the inductance for the new circuit. Okay. The region A, IL higher than IC. And then they say they want total impedance. G total. V total. Divide I total.
The total impedance
Okay.
is
What do you get?
33.33 ohms.
Can you say again for me, please?
Sorry, the total impedance is 33.33 ohms, or 100 divided by 3 ohms.
33.3, right?
Yes.
So make sure everyone get the same. How about the phase angle?
90 degrees.
Perfect. The thing is the circuitry on the inductor. Yeah, that will be N. Okay, so any question up to this point for this lecture for today? Also, very soon in the next in June, I will be teaching you how to working with the generator, how to working with the oscilloscope. You understand oscilloscope? We're using at school will be automatic. And also you have to understand for the scope for the manual. Okay. That means they not get much calculation. If you want it, you have to do your calculation. I given you example. For manual scope, they not given to you what the frequency value. So if you want to get a frequency, you have to measure the period T. And you have to apply formula F equal 1 over T to get the frequency. But if you're using your automatic scope, we're using at the school, then they do calculation for you. So you just press to see the frequency they will show you. Also, if you get a phone pick to pick, if they want to VIMS, then normally you have to do your calculation. You have to calculate the V peak, then apply the formula. VIMS equal V peak time 0.707. But the scope we're using at the school, that's a new one. They already calculate inside. You just press on VIMS, they display the value. So that's why you understand between two different types of the oscilloscope. In some company, they get just a manual analog scope. They not change to the automatic oscilloscope. Why? The reason is they said for analog, the old one still can get the job done. Why we have to change the new one? So that's why you have to deal with analog scope, not automatically. But we are school up to date. So that's why. Okay, so you get any question, anything?
I have a question. What is the button on the calculator for getting the phase angle? Arc 10?
On that, on number 5, right?
Right. Which
Okay.
button?
Now you get only HL. That means only inductor, right?
Right.
Okay, so you know. Okay, HL will be leading. The current, right? Now HL leading R, 90 degrees. Okay, so that's why the answer will be 90. You don't have to do calculation. The thing
Got
is
it.
you get only HL, nothing else.
Sorry.
If you get only HC, HC will be go this way. So they will be minus 90. That's only one. You don't have any resistance in here. If you get the resistance, you have to calculate 10 minus 1 of HL over R or HC over R, whatever. The reason we get 90, the thing is the circuitry only inductor.
So this is a given fact where since it's given that IL and IC will be 180 degrees out of phase with each other,
Exactly.
XR will be a 90-degree angle, no, a right angle. Okay, thank you, trigonometry.
So
Got it.
economic.
Understood. Mhm. I'm so happy to understand.
The thing is, I try to minimize to go detail on trigonometry. Okay. In the college, then you have to do. The thing is, they take you 2 years. On this program, normally 1 year maximum. So we just try to training for you. When you see the circuitry, at least you understand. Okay. Even you don't have to go detail to calculation. And also for the circuitry, you know how to apply the voltage, the sine wave, whatever, and how to measure, okay, the phase angle, the voltage. That's what I will be teach your guy in the AC1. How you can working on the lab. If you follow, you understand the lab is not a big deal. And also, we're helping you to do the unit test. Normally, after you're done, they get a unit test. Most of people get a big problem, cannot get over 70%. 70% will be okay. If it's less, you still have to do it. And to me, if you know how to do what to do, that's why you will really excited to working on the lab. You get the certificate sooner or later, depend on the lab. More you get it done, then you will be get the certificate. It's hard for to say how long. Now, I don't know. If you cannot get through the lab, take you maybe 2 years or 3 years or more, or never. We try to help your guy to be a technician. Okay? And this program, we already run for too many years, 37, 38 years. Okay? So we can, if you really want to learn, guarantee you will be a good technician. Okay? So let us stop this guy. So you get any question to me?
No, everything's okay. I understood.
Okay, if it's not, then good night,
Good night,
everyone.
Mr. Pham. Bye-bye.
Good night.
Good night, everyone.